Hello everyone, thank you for joining. I'm Harshit Jain, a software engineer at JioCinema, part of the personalization team. Today, we'll delve into the intricacies of how JioCinema recommends fresh and unwatched content to millions of customers, elevating their viewing experience. Our agenda will include an introduction to JioCinema, the methods we employ to ensure recommended content is not already watched, and a detailed exploration of technical nuances and challenges involved in this whole process. Firstly, let me give you a brief overview of JioCinema. We are an OTT streaming platform providing both free and subscription based video on demand and live streaming content. The sheer scale at which we operate is unprecedented, boasting over 10 million daily active customers. We cover a wide range of content, from streaming major sports tournaments like IPL, notably the most watched cricket league worldwide, and La Liga, to offering video on demand services in over 10 Indian languages. Personalization is the core of JioCinema's strategy. We curate personalized trays such as Because You Watched, language based recommendations, and top picks for you, and many more for each customer. These personalized trays not only keep the customers engaged but also enhance content discoverability, fostering long term engagement and reducing churn rates. However, personalization comes with its own challenges, particularly the issue of recommending content that the customers have already watched. To address this, we have implemented a solution and termed it as watch discounting. It involves removing the content that the customers have already seen, optimizing our real estate, and improving content discoverability. Let's explore the concept of watch discounting in action. Suppose a customer has already watched the popular show Game of Thrones, a series well known to a significant audience. For those who have enjoyed Game of Thrones, recommending a similar show like House of Dragons seems a very logical choice. However, it becomes crucial to avoid suggesting House of Dragons to customers who have already seen it. Implementing watch discounting allows us to optimize the use of valuable screen space by not recommending shows that the customers have already consumed. This strategy ensures we enhance customers' engagement and provide them more personalized experience by maximizing the relevance of our recommendations. Now, let's dive into technical nuances of watch discounting and role of CLADB plays in making this possible. Challenges abound, especially considering our vast customer base with over 10 million daily active customers and the additional complexity of handling 20 million concurrent customers during major events. To ensure smooth customer interaction necessitates meeting the latency and the availability targets within the SLA, irrespective of the scale and concurrency. Next, I'll now hand it over to my colleague Charan, who will unravel the technical insights and share how SELA-DB has been instrumental in overcoming these challenges.
Hey everyone, I am Charan Kamal and I am a software engineer at JioCinema, working with the personalization team and have close to 6 years of experience developing expensive distributed system at scale. Previously, I worked with Java but swiftly moved to Golang. And in my free time, you can find me playing either FIFA or you can find me just doodling around. So, yeah. Thanks, Harshit, for clarifying the problem statement and explaining the role of watch discounting. Watch discounting is really important for us to engage our customers at high throughput, keeping latencies low to ensure services talking to our watch discount service do not breach the agreed SLA thresholds. This is an interesting problem to solve in the space of personalization. Keeping the sheer size of our customer base and catalog in mind, we had to use a data structure which is space efficient as well as fast. While we want to keep our recommendations fresh, we also do not want to over engineer and make the system overly complex. Recommending a show or a movie that the customer has already seen wasn't a deal breaker to us, which calls for a probabilistic data structure that takes very small space and can do blazing fast lookups with occasional false positives. I'm confident that by now, most of the audience has realized that we are referring to Bloom filters. Once we zeroed in on using Bloom filters, we had few options to explore, and all of them had their own challenges, which we will speak about. To begin with, we explored how about building our own Bloom filters. As such, building Bloom filters is a fun exercise, but we also have a massive scale to consider. At the scale of JioCinema, over 10 million daily active customers consuming hundreds of thousands of content every day. With our customer base, we could not just have a map of Bloom filters, hoping we could scale vertically as our customer base increases. Scaling horizontally would either require sticky sessions based on which pod holds the Bloom filter for that customer, or replicate the same data to every pod in the system. Would it be fun cracking this massive problem? Yes, it is. Are there off the shelf product that we can explore? Yes, we do. As much as the engineer in us wanted to solve this problem and implement a service that would store and serve content based on the Bloom filter, we choose to go with a well tested system that could handle this massive scale. Once this decision was made, we started evaluating off the shelf products like SelaDB and Redis. So, why not try Redis Bloom filter capabilities? To test our hypothesis, we set up an open source cluster with Bloom filters enabled and ran load test. During this activity, we faced an interesting problem with Redis cluster topology. Seldom, if a node gets hot, it would get into a failover promoting its slave as master, and the entire node within the cluster would be unusable, while the dance between master and slave of promoting each other would continue. We recognize the risk associated with the existing setup, prompting us to explore Redis Enterprise. After configuring Redis Enterprise with Bloom filters enabled and conducting the same test, we observed a significant improvement in performance, meeting all our SLAs well within the cost limits. However, there was a catch. In the OTT business, ensuring sub-millisecond latency for content delivery across multiple regions is crucial. This meant that even with Redis Enterprise, we faced a choice between an active deployment to maintain low latency or compromising the customer experience in certain regions. The latter was unacceptable for our use case. Additionally, Redis Enterprise imposed substantial charges for each operation and replication, making it challenging to justify the return on investment of this feature for our business. This led us to explore SelaDB. SelaDB not only supported Bloom filters out of the box, but we also had prior experience using it for different personalization use cases, knowing its exceptional speed. With the capability to replicate data into multiple clusters and serve customers from locations close to their origin, SelaDB seemed like a comprehensive solution. This allowed us to concentrate on developing what mattered most for our customers and enable us to go to market fast. So now the next question would be, how are we using and optimizing SelaDB to power watch discounting and serve fresh recommendation? Well, we have two ingestion pipelines. We have batch processes, which computes customers' watch history within a specified window, and based on the rules of completion, we decide if the show has passed the definition of watched or not. If it has passed the criteria, we update the table in SelaDB for a specified TTL so that after a specified duration, we can either mark a show rediscoverable for the customer to enjoy them again. While JioCinema is recognized as the premier sports and entertainment destination in India, we also invest significantly in creating supplementary content to maintain high engagement levels with our customer base. These shorter content pieces, lasting around 30 to 60 seconds, revolve around our primary content. Given that customers consumes these shorter versions more frequently, it is imperative for us to promptly apply watch discounts to them. Instead of batch processing the data next day, we strive for real-time streaming of this information into our watch discounting repository. As mentioned earlier, adopting ScyllaDB enabled us to prioritize the development of functionality over the creation of the data structure. This approach allowed us to keep our nodes small and maintain a clear separation of concerns between Bloom filters and filtering watched content. The unmatched performance of ScyllaDB became evident, especially when dealing with high cardinality of partitions and small data sizes, precisely the characteristics of our dataset. TTLs made cleanups easy and permitted the discovery of watched content after a specified period. Moreover, reading from local quorum ensured that we could access data from the closest region to the customer, resulting in high throughput and lower latencies. This strategic combination of features in ScyllaDB significantly contributed to the efficacy and effectiveness of our system. So, enough talk and time for some stats. In a recently concluded cricket tournament between India and Australia, we saw a surge of customers coming in when the match started, creating a distinctive hockey stick pattern in our monitoring dashboards. As it can be seen, we had enabled the feature at multiple places in our app and saw a massive spike on our services, but the resiliency of ScyllaDB was unparalleled to ensure all our SLAs were met, as we can see from the P95 latency of our monitoring dashboard as well. Thanks for attending the session. If you have any queries or any feedback, feel free to connect. Here's our contact information.